To determine the wire size for a subpanel, we first need to calculate the total load. Let's go through the loads provided. The electric water heater is 1500 watts. The window air conditioner is 1275 watts. The TV, satellite receiver, VCR, and computer we will estimate at 500 watts. The lights, 3 at 100 watts each, total 300 watts. And the electric heater is 1200 watts. Adding these together, 1500 plus 1275 plus 500 plus 300 plus 1200 gives us a total load of 4775 watts. Now, referring to a wire size chart for copper conductors, a 10 American wire gauge wire is suitable for a load up to 50 amps and can handle the calculated load of 4775 watts. To determine the amperage needed for the subpanel, divide the total load by the voltage, which is 120 volts. So amperage equals load divided by voltage. In this case, it's 4775 watts divided by 120 volts, which equals 39.8 amps. Based on the calculated amperage of 39.8 amps, it is recommended to use a 40 amp subpanel with a 40 amp circuit breaker installed. Remember to use copper wires and appropriate conduit for protection. It is also advisable to install a surge protector on the subpanel to protect appliances from power surges. And consider adding additional capacity in the future if you plan to connect more appliances or equipment to the subpanel. It is highly recommended that the wiring is done by a qualified electrician to ensure safety and compliance with local electrical codes. When installing a subpanel, several crucial safety and code compliance aspects must be taken into account. Firstly, grounding is paramount. The subpanel must have a separate ground wire that runs back to the main panel. This ground wire should not be confused with the neutral wire, which carries the return current. The ground wire is there to provide a safe path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Secondly, bonding is essential for safety. Bonding refers to the connection of all metallic parts of the subpanel and any metallic enclosures to the grounding system. This ensures that all metal parts are at the same potential, minimizing the risk of electric shock. Thirdly, overcurrent protection is necessary for each circuit. Each circuit in the subpanel must be protected by a circuit breaker or fuse of the appropriate size. The size of the overcurrent protection device should match the ampacity of the wire used in the circuit. Fourthly, wire sizing is critical. The size of the wire used to feed the subpanel must be adequate to carry the expected load. The wire size should be determined based on the ampacity of the circuit breaker protecting the subpanel. Fifthly, conduit and cable protection are important. Wires must be protected from physical damage by running them through conduit or using appropriate cable types such as Romex or armored cable. The type of conduit or cable used depends on the specific application and local electrical codes. Sixthly, proper connections are necessary. All electrical connections must be made properly and securely. Loose connections can cause arcing, which can lead to fires. Seventhly, labeling is helpful. The subpanel must be labeled to indicate the circuits it serves. This makes it easier to identify and troubleshoot circuits in the future. Eighthly, local electrical codes must be followed. All electrical work must comply with local electrical codes. These codes are designed to ensure the safety of electrical installations. Ninthly, permits and inspections are often required. In many jurisdictions, a permit is required for electrical work, and the work must be inspected by a qualified electrical inspector. Tenthly, professional installation is recommended. Electrical work can be dangerous. It is recommended to hire a qualified electrician to install the subpanel. A qualified electrician will have the knowledge and experience to ensure that the installation is done safely and correctly. In addition to these safety and code compliance aspects, there are also several practical considerations to keep in mind when installing a subpanel. Firstly, location is important. The subpanel should be located in a dry, accessible location. Secondly, capacity is a factor. The subpanel should have enough capacity to handle the expected load. It is always better to have too much capacity than not enough. Thirdly, future expansion is something to think about. Consider future expansion when selecting a subpanel. It is easier to install a larger subpanel now than to have to replace a smaller subpanel later. Fourthly, ease of access is important. The subpanel should be easy to access for maintenance and repairs. Fifthly, aesthetics should be considered. The subpanel should be installed in a way that is aesthetically pleasing. When calculating the load for the subpanel, it is important to consider all of the appliances and equipment that will be connected to it. This includes not only the items that are currently connected, but also any items that may be connected in the future. To calculate the total load, add up the wattage of all of the appliances and equipment. If the wattage is not known, it can be estimated based on the voltage and amperage of the appliance or equipment. Once the total load has been calculated, divide it by the voltage to determine the amperage. The amperage is the amount of current that the subpanel will need to be able to handle. The size of the wire used to feed the subpanel must be adequate to carry the amperage. The wire size should be determined based on the ampacity of the circuit breaker protecting the subpanel. The circuit breaker should be sized to protect the wire from overheating. If the wire is too small, it can overheat and cause a fire. The circuit breaker should also be sized to protect the appliances and equipment connected to the subpanel. If the circuit breaker is too large, it will not protect the appliances and equipment from overcurrent. The subpanel should be grounded to protect people from electric shock. The ground wire should be connected to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode should be located as close as possible to the subpanel. The subpanel should also be bonded to all metal parts of the electrical system. Bonding is the process of connecting all metal parts of the electrical system together so that they are at the same potential. This helps to prevent electric shock. All electrical work should be done by a qualified electrician. Electrical work can be dangerous, and it is important to hire someone who knows what they are doing. A qualified electrician will be able to install the subpanel safely and correctly. It's also crucial to consider voltage drop over the 100-foot distance. Voltage drop is the decrease in voltage that occurs as electricity flows through a wire. The longer the wire, the greater the voltage drop. Excessive voltage drop can cause appliances and equipment to malfunction. To minimize voltage drop, use a larger wire size. The larger the wire size, the lower the voltage drop. There are voltage drop calculators available online that can help determine the appropriate wire size for a given distance and load. It is generally recommended to keep voltage drop below 3%. Also keep in mind that the National Electrical Code, NEC, provides tables for allowable ampacities of conductors. These tables take into account the type of insulation, the ambient temperature, and the number of conductors in a raceway or cable. It is important to consult the NEC to ensure that the wire size selected is adequate for the application. For example, NEC Table 310.15. B16 provides ampacities for insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius in free air. These ampacities are based on an ambient temperature of 30 degrees Celsius. If the ambient temperature is higher than 30 degrees Celsius, the ampacity of the conductor must be derated. In addition to the NEC, local electrical codes may also have requirements for wire sizing and installation. It is important to consult with the local electrical inspector to ensure that the installation complies with all applicable codes. When selecting a subpanel, it is important to choose one that is rated for the appropriate voltage and amperage. The voltage rating of the subpanel must match the voltage of the electrical system. The amperage rating of the subpanel must be greater than or equal to the total load that will be connected to it. Subpanels are available in a variety of sizes and configurations. Some subpanels are designed to be surface-mounted, while others are designed to be flush-mounted. Some subpanels have a main breaker, while others do not. The type of subpanel that is selected will depend on the specific application. When installing a subpanel, it is important to follow the manufacturer's instructions carefully. The manufacturer's instructions will provide detailed information on how to install the subpanel safely and correctly. It is also important to use the proper tools and equipment. Using the wrong tools or equipment can damage the subpanel or cause an electrical shock. Also be sure that all connections are tight and secure. Loose connections can cause arcing, which can lead to fires. After the subpanel has been installed, it is important to test it to make sure that it is working properly. The testing should be done by a qualified electrician. A qualified electrician will be able to identify any problems with the installation and correct them. Finally, remember that safety is always the top priority when working with electricity. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself from electric shock. Therefore, always consult a qualified electrician for any electrical work to ensure safety and compliance with local codes. They can provide expert advice on wire sizing, subpanel selection, and proper installation techniques. Their expertise will help to ensure a safe and reliable electrical system for the mobile home.